The objective of this presentation is to understand analog representation and digital representation of the quantity. So let's start. In most fields of the life, it may be science, technology or business, we are constantly dealing with the quantity. Example of quantity can be temperature, sound, clock time, etc. So it is required to have good representation for these quantity values so that we can handle this quantity efficiently and accurately. There are two ways which are used to represent the value of quantity. The one is analog and second one is digital. So first let us look at analog representation of the quantity. So what happens in analog representation of the quantity? Yes, in analog representation of the quantity is represented by continuously variable and proportional indicator. Please try to understand my word. So what happens in analog representation of the quantity? The quantity is represented by continuously variable and proportional indicator. What is meaning of this? Let's try to understand it by using example. Let's take example of analog representation of speed of the car. In automobile speedometer, the deflection of the needle is proportional to speed of the car. As the car speeds up or slow down, accordingly the needle position is going to change. This is analog representation of the speed. Now let's look at second example, and it is mercury thermometer. In mercury thermometer, we use column of mercury whose height is proportional to the temperature. As temperature increases, the height of the mercury also increases and vice versa. So this analog quantity has one important characteristics, that is they vary over continuous range of the value. They have continuous values. For example, the automobile speed, it can have any value between 0 and say 100 km per hour. Similarly, the temperature value in mercury thermometer, it can be any value from say 35 degrees Celsius to 42 degrees Celsius. So actually in these two values, that is 35 degrees Celsius and 42 degrees Celsius, again we can have infinite number of values. Now let's look at digital representation of the quantity. Now in digital representation of the quantity, we don't use continuously variable indicator for representing the quantity. Rather, here we make use of the symbol called digit. Consider example of digital clock, which provide time of the day in form of decimal digits that represent hour, minutes and second. The time of day changes continuously. Okay, time of the day changes continuously, but digital clock reading does not change continuously, but it changes in steps of 1 per minute or per second. So when 1 second is completed, some digit in digital clock is going to change, or when 1 minute is completed, then corresponding digit present in digital clock is going to change. Okay, in other words, this digital representation of the time of day changes in discrete steps. Okay, so second will be initially 1, then 2, then 3. Okay, so this change will take place in discrete steps. Other example is digital speedometer, in which speed of the car is shown by digits and not by dial or needle. The major difference between analog and digital quantity is that analog quantities are continuous values. Just now I told you that the analog in case of analog quantity, we can have infinite number of values. Okay, so analog quantities are continuous, while digital quantities, they are in discrete form. Due to discrete nature of digital representation, there is no ambiguity when reading the value of digital quantity. But this is not case with reading time from analog watch. So this is regarding representation of the quantity in analog form as well as in digital form.